Camera roll. Good morning, good afternoon, good evening, good part of day, everyone. Thank you for joining our weekend session at Large Scale Scrum meetup of New York City, the largest, fastest growing, and the hopefully one of the most active, if not the active, the most active global meetup, at least in the LESS community. Today, I will have a very special guest, and I would like to give a quick shout out, a quick word of introduction to our guest. His name is Thierry Depew, and he's a guest from Belgium. He is a very experienced lean software and operations engineer. He has a very strong background in software development, and he's a strong advocate and a jack of all trades when it comes to CI/CD pipeline and in general to development. His specific passion is in creating meaningful IT systems with a focus on code quality and efficiency for IT delivery processes. In his personal view, and he will expand on this in depth, instead of balancing, quote unquote, between high quality and fast delivery, in which case we oftentimes see compromising one or the other or both. We should really strive for practices that lead to better quality, that have more and better delivery. So this is not dichotomous, this is not binary, one or the other. It should be both. Currently, Thierry works for the fintech startup called Tax Familia, but also he's the founder of Thinking Labs, his own company, through which he advises organizations in the adoption of continuous integration and continuous delivery. So today he will be taking us through this very interesting topic. And the reason why it's actually very relevant to large scale Scrum is because what he's about to cover will have a lot of coupling, a lot of relevance to engineering practices that we recommend in lean agile software development, and LESS is very big in that. So with any further ado, Thierry, I would like to pass the baton over to you. Thank you very much for being here at this hour, and the floor is yours.
Thank you very much, Gene, for having me. All right, well, let's go. So, all right, this is not working. How is that possible? This is annoying. Please. All right. So I'm first going to introduce you to two quite different teams I have worked with in my past career. So beginning 2012, I had the opportunity to start a technical coaching mission with the purpose to upscale the software engineering skills of a rather novice team. So novice from an engineering perspective, not so much from a working experience perspective, because yeah, they had working experience ranging from 5 years till 20 years. Well, they just didn't have the luxury to work with people that showed them different ways of working, or to go to conferences where they could learn different ways of working. Now, luckily, I wasn't alone coaching that team. We were the two of us, which is quite reassuring, especially if you have to introduce quite a lot of change in front of people with lots of working experience. Now, when we start, we discovered a situation we weren't quite expecting to still discover in 2012. No one in the team, except for one person, was using any version control system. So code was shared among team members through shared drives, and production deployments happens, well, obviously from shared drives. So the first thing we did was actually to introduce version control system. Now, because the team was quite novice in using version control, well, we thought that Git would be a bridge too far. It's just too many concepts to learn from the start. And so, well, we went for subversion because it's quite simple. You only have 3 concepts. You check out code, you modify it, you check it in, and you're done. It's fairly simple. Now, it was also said at the time that, well, branching was rather painful with subversion. And so I suggested, well, we won't do any branching at all. Everyone is going to commit directly into Trunk, and that worked pretty well because, well, there was a second thing we introduced right from the start, the practice of continuous integration and team commitment that any change had to be covered by automated tests, and preferably unit tests. Now, at the time, I didn't realize this way of working was in fact a valid branching strategy. And it's only years later that I learned that this was called Trunk-based development. Now, was Trunk never broken? Well, yes, it was. So, and sometimes more often than actually good. But remember, this is a novice team, and it wasn't really a problem. We had continuous integration in place that discovered the problems early and allowed us to fix them while they were still small and easy to fix. Now, when the team gained more maturity and had more confidence in using a version control system, well, we decided it's time to migrate to Git. And the main driver for this was there is just more tooling available for managing Git repos, and we wanted to use the pull request model for code reviews. And so we wanted to be able to create branches more easily. Now, what works for the open source community, where you have a core team managing a system and that accepts contributions from the outside world, doesn't necessarily work for a collocated team inside a corporate environment. So, like with all powerful tools, well, there are many ways you can use distributed version control systems, and not all are good. And Jess refers here to the use of feature branching and the fact that proponents of distributed version control systems rely on feature branching to sell distributed version control systems. And together with all the tooling that exists around distributed version control systems, it makes everyone blind to the problems that are related to the use of feature branches. And we've hit those problems quite hard. And we've tried to find solutions by introducing ever more complex processes and ever more complex technology, but it never really solved the underlying problem, except introducing more complexity. And so in the end, well, we sat together to discuss the matter, and we've just decided to let go on the use of feature branches and go back to what worked for us, which was Trunk-based development. And we never looked back. And interestingly, in January of this year, I had the opportunity to give the same presentation inside that same organization again, many years later. And surprisingly, I've learned that the team was still applying Trunk-based development. And they just can't imagine a different way of working. Now, after that mission, in 2016, I had the opportunity to start a collaboration with a totally different organization, a very agile organization, working with highly skilled engineers, where everyone was pairing almost full time. But they decided as an organization to use Git flow as a branching strategy. And so when I arrived, I've discovered branches living from somewhere 5 days till 30 days. And I saw team members constantly rebasing master into their branch and fixing merge conflicts and spending lots of invaluable time fixing, doing rework and fixing merge conflicts. And so, well, with the experience I had working with this novice team, I suggested, why wouldn't we try out Trunk-based development? Can't we do an experiment? And at the time, a new project was going to start where only 2 team members was planned to be working on. And so it wasn't going to be very riskful. Now, trying to convince people of the benefits of Trunk-based development is really not an overnight task. So whenever I suggest Trunk-based development, and especially in front of experienced engineers, I always get the same reaction. People stare at me like I am a moron. Are you insane? the whole industry is using some sort of branching strategy, and you're just suggesting everyone in the team is going to commit directly into mainline. It's going to be a mess. We will have merge conflicts all over the place. Now, although string-based development is implied by continuous integration, and although it has been reported since 2015 in the State of DevOps report to predict high software delivery performance, and although organizations like Facebook and Microsoft and Netflix and Google apply string-based development at very, very large scale. So for Google, we're speaking in 2016 about 25,000 developers working on one single string with 16,000 changes per day. It is still one of the most controversial practices in the IT industry. And so I failed. I miserably failed in trying to get that organization to just run a small experiment with string-based development. And the main reason for this was that, well, I lacked the right arguments because I only had this one experience working with this one team. Although in my past career, I've used many different branching strategies, but I never really observed what happened when using branching strategies and which problems arise from that. And so I took this opportunity to just observe what happens. And this resulted in this presentation. Now, before we move on, I want to introduce some definitions.
It's a global conversation. Dito, BMW.
Can you please mute?
Actually, hindi na sila nagpo-produce niyan.
Hello, can you please mute?
Volkswagen.
Can you please?
Can you mute everybody except?
Thank you so much. So before we move on, I would like to introduce, well, some definitions of some practices. Now, I'm sure you know these practices, but well, as it often happens in the IT industry, people like to redefine practices to make sure they match the way they work. So therefore, I want to reintroduce them just to make sure we are all aligned. So what is mainline? So mainline is the line of development, which is the reference from which the builds of your systems are created that feed into your deployment pipeline. So for Git, this is master. For Mercurial, this is your default branch, and for Subversion and CVS, this is string. What is feature branching? Well, feature branching is a practice where people do not merge their work into mainline until the feature they are working on is done, but not yet done. So done means it is dev complete, but there is still a lot of work to be done before that feature gets into production. So you first have to create a new build, then you have to run all the automated tests, then you have to perform manual exploratory testing. Eventually you have to run security and performance tests, and only then you can deploy into production, and then you have to run your smoke tests, and eventually you can then release to the end user. So when you have done all of this, your feature is done. So with feature branching, the implementation starts with the creation of a branch, then the feature grows on that branch. And when the branch is finished, well, it goes through a gating process that is called a code review. And when it goes successfully through this gating process, it gets merged into mainline. So when we are speaking about feature branching, we are really speaking about long-running branches, meaning branches that live longer than one day. What is continuous integration? Well, continuous integration is a practice where members of a team integrate their work frequently. Usually each person of the team integrate at least once a day, leading to multiple integrations per day for the whole team. And each integration is verified by an automated build. So it's a practice that ensures always working software on mainline, and that gives you feedback within minutes on whether a change broke the application or not. And this involves that everyone in the team commits at least once a day into mainline Every commit triggers an automated build and execution of all the automated tests. And if the build happens to fail, it gets fixed within 10 minutes. And the easiest way to fix a broken build is just to revert the last commit that caused the broken build and go back to the last known good state. Now remember, continuous integration is really a practice. You don't need much tooling for this. James Shaw wrote a very funny article regarding this. It's called Continuous Integration on $1 a day. So the only thing you need is a version control system, an automated build, a crappy build computer, a silly toy, and team commitment to never break the build. And what is the goal of any organization? Well, the goal of any organization is to sustainably minimize the lead time to create positive business impact, where lead time is your clock wall time between we as a team or an organization have an idea, that idea gets implemented and it gets deployed into production and released to real users. And positive business impact is anything that creates money for your organization. This is your turnover, saves money for your organization. These are your cost reductions, or protects money for your organization. This is being ahead of your competition. Now, we want to reduce the lead time because we want to accelerate feedback. We want to know as fast as possible if the thing we have just implemented and deployed into production is actually being used and how it is being used. And based on that information, we can take new decisions and run new experiments to find new unmet needs of our customers and find new ways to delight our customers, which is a huge competitive advantage. Now, before I could ever suggest string-based development again, I had to understand why teams are using long-running branches. What problems are they trying to solve by using long-running branches? And so I asked around and I asked proponents of feature branches for their reasons. And I got 4 reasons. And the first one was, well, it allows us to work in isolation, therefore we are more productive. And the first time I've heard this, I was like, yeah, fair enough. Seems obvious. And then I thought this through and I was like, but wait a minute. This feels like a local optimization. We are optimizing here for individual developer productivity. But developing a software product is rarely an individual activity. It is most of the time a team activity. And so the team will only go as fast as the slowest merge. As long as you haven't merged back, well, you simply don't know how much work is left to do because of potential merge conflicts that will happen and potential rework that will have to happen to fix those merge conflicts. And so integrating changes into mainline becomes a very time-consuming and very unpredictable activity. And this makes your whole IT delivery process very unpredictable and will inevitably increase your lead time and your time to market. And remember, the goal of your organization is to sustainably reduce the lead time in order to create positive business impact. So therefore, instead of optimizing for developer productivity, we should optimize for team productivity and adopt a team-oriented branching strategy. The second reason I got was, well, if we have a refactoring that goes nowhere, we can just delete it. And again, this seems fair, does it? However, what I think they are trying to say is, well, look, we have this problem where we don't know the solution right away. So we just try something. So we just write some code and we commit code into a remote branch, hoping that somewhere we will get to a solution. And if we don't, well, it doesn't matter. We can just delete the work by deleting the remote branch. Now, if you don't know the solution to a problem right away, why don't you spike out some ideas? And this is the exact purpose of a spike, to write some throwaway code to test out an idea. And the output of a spike is not production code. The output of a spike is knowledge. After a couple of hours, well, you should know if your idea worked out or not. If it didn't, throw away the code and try out another idea. If it did work out, fantastic, you found a solution to your problem. Yay! Again, throw away your code and start over again, but this time implement the solution in small incremental steps using the knowledge that you have just created during that spike. The third reason they gave me was, well, it allows us to control the quality of what goes into production. Because, well, only features that went successfully through a quality gating process called code review get merged into mainline and as such will be deployed into production. Now, isn't controlling the quality the exact purpose of having continuous integration and continuous delivery in place? So the objective of continuous integration and by extension continuous delivery is to eliminate bad quality release candidates as early as possible. Only changes that successfully went through all stages of the deployment pipeline and that have been thoroughly tested get into production. And in my humble opinion, this is the only effective way to control the quality of what goes into production. And the last reason I got was, well, it allows us to control which features get into production, or more precisely, it allows us to prevent that unfinished functionality get deployed into production, because unfinished functionality is sitting on a feature branch. And as long as that feature branch hasn't been merged back into mainline, well, the feature doesn't get into production. Now, what we are actually doing here is using our version control system to turn features off and on through manual merging, which is nothing else than a poor man's modular architecture. So instead of using our version control system as a manual toggling mechanism, we should design our systems in such a way that we can turn our features off and on at deploy time or at runtime. Now, why is using feature branches such a problem? Well, first of all, it delays feedback. So as long as we haven't merged back to mainline, well, we simply don't know if our changes broke the application or not. So continuous integration is only triggered the moment we merge back into mainline. Now, this delay in feedback increases with the duration of the branch and with the number of parallel branches. So if the branch lives for a couple of hours, feedback is delayed for a couple of hours. If it lives for a couple of days, well, feedback is delayed for a couple of days. Now, remember, continuous integration is this practice that ensures always working software and that gives you feedback within minutes, whether a change broke the application or not. Now, lots of teams like to redefine continuous integration by saying, well, look, we have our GitLab running against all of our branches. Well, having an automated build running against all of your branches is actually a really, really good thing, but it is not continuous integration. You are not integrating. The only feedback you get is whether the code that exists inside this isolated branch still compiles and whether you haven't introduced any regressions against the tests that exist inside the branch. So you don't get any feedback on whether your changes integrate well with the changes sitting around on all other parallel branches. So from this moment on, CI doesn't stand for continuous integration, but stands for continuous isolation. You are not integrating outside changes, and the rest of the team don't know how your changes will integrate with their work. If we are developing multiple features at the same time in parallel, integrating these features becomes exponentially more difficult with the number of features that are being developed in parallel and the number of changes required to implement these features. Now, one way to avoid this integration problem is using what Martin Fowler calls promiscuous integration. Now, be aware, Martin doesn't advise the use of promiscuous integration. He just named the pattern. Now, in order to use a change that exists in another branch, well, we are going to cherry pick some commits from that branch into our branch. And so we are actually communicating changes between branches. Now, the biggest concern Martin has against promiscuous integration, apart from introducing quite a lot of process complexity, is that with all the cherry picking, well, we lose track on who has what on which branch. Now, compare this complexity with the simplicity of having everyone in the team committing immediately into mainline, and as such communicating their changes immediately with the rest of the team, which creates a shared understanding and a collective ownership of the code base. And well, inevitably, this will result in a better quality of the product and in a higher throughput of the IT delivery process, and which will reduce your lead time and your time to market. Now, as long as we haven't merged back into mainline, well, the rest of the team simply don't know in which direction we are taking the code in order to implement the feature we are working on. Now, this is fine if everyone in the team is working on different parts of the application. But the minute two team members are working on the same code base area, they are each blind to how their work affects the other person. On the other hand, if we are committing more frequently to mainline, well, we communicate to the rest of the team the direction we are taking with the code to implement the feature we are working on. So, for example, we could introduce a conditional indicating where the new code starts that we are adding for that feature, and have this conditional disabled by default. So then the rest of the team can see the new changes and see how this change affects their work, and they can just adapt immediately. Now, you could argue that introducing this conditional increases the complexity of the code base because, well, a conditional means branching logic in the code. So, well, you are right. It will increase complexity. Now, on the other hand, by not introducing this conditional and using feature branches, well, the conditional is not gone. It is still there, but it is less obvious and absolutely not visible, because from then on, well, your conditional is your version control system branch. And from that moment on, well, your changes are invisible for the rest of the team. And they have absolutely no idea how your changes will impact their work. So remember, a version control system is not only there to version source code, it is first and foremost a communication tool to communicate the changes with the rest of your team, which again will help gaining a shared understanding of the system and a collective ownership of the system, which will again lead to better quality and higher throughput. Now, because feature branches hide work for the rest of the team, it discourages the adoption of refactoring. Now, when we are just adding new code to the code base, integrating this new code is fairly straightforward. But if we are refactoring the code, well, we are introducing new concepts, new abstractions, and version control systems are absolutely not aware of semantic changes, which makes merging very difficult. So if we have two team members working on a code base, each working in parallel on their isolated branch, if one person refactors and merges back early, and the other person has a significant amount of changes on their branch, merging back to mainline for that second person will be far more painful, and probably it will also introduce quite a lot of tension inside the team. Now, the longer the branch lives, the more refactoring we perform on that branch, the harder it becomes to merge back into mainline because of all the potential merge conflicts that will happen and all the potential rework that will have to happen at merge time. And so merging back becomes again time consuming and very unpredictable, which will inevitably slow down the team. And it is the slowdown of the team that discourages the adoption of refactoring inside the team. Now, we all know that not enough refactoring prevents paying back the technical debt. And not paying back the technical debt makes adding new functionality to the code base harder and harder and more time consuming, which again will slow down the team. And so we end up in this vicious circle where the team slows down over time, eventually comes to a halt, and nobody actually understanding why and how we got there. Now, when using feature branches, we are in fact introducing batch work. The longer the branch lives, the more changes are accumulated on the branch, the bigger the batch size becomes, where the batch size is the number of commits that exist since the beginning of the branch. And the bigger the batch size is, well, the more work we have in progress. And work in progress is nothing else than inventory. And inventory is just money. Money that is stuck into the system. It is stuck into the system because the organization invested quite a lot of money to create this inventory, to create all this code that exists on all these parallel branches. But this investment doesn't generate any revenue for the organization. As long as we haven't merged back into mainline, deployed into production and released to our end users, well, we don't create any value. So we don't get any feedback. It's only when this code gets merged into mainline and deployed into production that we actually get feedback on how this code behaves in production and how it is being used by our users. And it's only then that we can find new ideas to satisfy our users. Now, to reduce this inventory, we know from lean manufacturing, we have to reduce our work in progress. And so this means working in smaller batches, reducing the lifetime of the branches, committing more frequently to mainline, which means integrating more often and thus achieving a state of continuous integration, which brings us closer to a single piece flow. And we know from lean manufacturing, again, that a single piece flow will increase our throughput and reduce our lead time and our time to market. Now, because feature branches introduce batch work, it also creates bigger change sets, and bigger change sets means more risks. So if we are committing frequently into mainline, while the continuous integration process will process smaller change sets. So if the build happens to break, finding the root cause will be fairly easy because the change set is so small, and probably also because we've just integrated the failing change 5 minutes ago. And so we have enough context to fix that build more easily. And so we will be able to fix the build within 10 minutes. On the other hand, if we are using feature branches, we are merging less often to mainline. And so as a result, the continuous integration process will have to process bigger change sets. So if the build happens to break, finding the root cause will be far more difficult because the change set is so big. And also maybe because we have introduced a failing change a couple of hours ago, or worse, a couple of days ago. So we don't have this context anymore to easily fix that build. And so from this moment on, well, fixing the build will take far more time. And so while we run the risk of having a broken build for a very long period of time. And so we have just lost the monitoring of the health of our application. And so we also lost the ability to perform on-demand production releases at any given moment in time, which will increase your lead time and your time to market. And lastly, well, it creates lots of overhead for the team members. So to start a feature, well, we have to start by creating a branch and push the branch to a remote repository. To reduce merge complexity, well, we have to rebase mainline into our branch frequently. To communicate changes between features, well, we have to cherry pick commits between branches. If we have to switch work between features, which is never a good idea, but while it happens, well, we have to switch between branches. And lastly, when the feature is done, we may not forget to delete the branch, otherwise we run the risk of having a repo full of branches that are not used anymore. So in order to implement a feature, well, team members need to perform lots of operations on a day-to-day basis. And so while they have to remember a large set of version control system commands, and this creates cognitive overhead that could slow down the team. Now, compare this complexity with the simplicity of having everyone on the team committing frequently into mainline, reducing redundant effort and simplifying the workflow. So the only thing we need to do is pull the latest changes from the remote repository, add our local changes, commit, and push. It's fairly easy and it's fairly simple. Now, how can we avoid the problems introduced by feature branches? Well, by adopting continuous integration as it was meant when introduced by the extreme programming community in the late 90s, ensuring always working software mainline, allowing us to perform on-demand production releases from mainline at any given moment in time, which this is the most critical practice to adopt to enable the fast flow of work through the value stream and getting close to a single piece flow. And this implies the adoption of trunk-based development. So trunk-based development is what individuals practice or what pairs practice in order to achieve continuous integration as a team. It is a version control strategy in which everyone commits multiple times a day to mainline. As a result, changes are small, merge conflicts are very unlikely, and the code base is always in a releasable state. Testing happens on mainline, and ideally production releases happen from mainline. If a release needs some stabilization, well, we can opt to create a short-lived release branch and release from the release branch, but fixes are done on mainline and cherry-picked into the release branch. So this allows us that after the release, we can just delete the release branch without having to merge back to mainline. Now, crank-based development is really not a recent new hype, as I sometimes read on Twitter. It is in fact there since the early 80s, when RCS was created as one of the first version control systems. It supported branches, but teams were very cautious and stuck to trunk. Now, how do we achieve continuous integration? How do we prevent it becomes a mess when everyone in the team commits multiple times a day to mainline? Something teams are most afraid of. Well, we have several practices at our disposal to achieve a state of continuous integration, and I am going to present 4 of them. But there are, in fact, far more practices that support this. So recently, I've identified somewhere 14 practices that make continuous integration. And the first practice is, in my humble opinion, the most important one, but from what I see, seems to be the hardest one to adopt. Incremental software development. Breaking large changes into a series of small incremental changes that keep your system always working. So Steve Freeman and Ed Price makes this analogy with surgery in their book, Growing Object-Oriented Software Guided by Tests. So surgeons prefer keyhole surgery over opening a patient's body because it is less invasive and cheaper. While for the same reasons, we prefer to work in small incremental steps because it is less invasive. We are not ripping apart the application. Therefore, it is cheaper because we keep the application always working, and so we can perform on-demand production releases at any given moment in time. But this means several things, and it means that you only commit on green. And this is where test-driven development supports continuous integration. You start by writing a small failing test. You add just enough code to get the test passing to green. You commit and you push. And then you start refactoring. If it is still green, you commit and you push. So test-driven development creates this commit cadence that you need to achieve a state of continuous integration. Second, you absolutely need a decoupled code base. When a code is too coupled, it is very difficult to adopt incremental software engineering skills. Any change to the code base will ripple through the whole code base, ripping apart the application, making sure the application is not working for a long period of time, and so preventing you to perform on-demand production releases. So this is why adopting architectures like ports and adapters, also known as hexagonal architecture, and some of the solid principles are so important. They will not only have a positive impact on code quality, but they also will have a very positive impact on throughput and time to market. And lastly, you absolutely need lots and lots and lots of very, very, very fast tests. You need lots of tests to gain the confidence that you aren't introducing any regressions when committing frequently into mainline. And they need to be very fast to allow everyone in the team to commit frequently into mainline, because you have to run all those tests before committing into mainline. Now, when tests are not fast, 2 things can happen. Either people do not run them before committing to mainline, and so running the risk of introducing regressions, or they tend to run them less frequently, and so they start batching up work, and because they are committing less frequently, and this will delay the feedback, which will have a negative impact on quality and on throughput. The second practice is the most easy one to adopt. If you have unfinished functionality, just hide it. It is perfectly acceptable to have unfinished functionality sitting in production, even sitting behind a publicly accessible URL, as long as it is not discoverable by the end user. So you don't need any fancy feature toggling for this. So for instance, you are adding a new screen to a user interface, but it's not yet finished. Well, as long as it is not finished, don't add a menu item to the navigation menu. Only add this menu item at the end when the screen is finished. The same is true for API endpoints. As long as an API endpoint is not finished, well, don't document it. If you have to perform large-scale refactoring that could rip apart the application for a long period of time, so let's say you want to replace a library by another one. For instance, you want to replace your object relational mapping library by another, or let's be crazy, you want to replace the object relational mapping by plain old SQL, or you want to replace your user interface framework by, let's say, GSPs with servlets by Rails on the GVM, or you want to upgrade the user interface framework, or you want to replace an algorithm by a far more performant algorithm. So instead of using branch by version control, which is usually used in these circumstances, well, use branch by abstraction. So branch by abstraction is a practice that allows you to perform large-scale refactorings in small incremental steps, keeping your code base always working and still being able to perform on-demand production releases, and more importantly, still being able to add new functionality while refactoring is still going on. So how does it work? Well, we begin with a situation where various parts of the software are calling a supplier code. This is this algorithm you want to replace, or this library. First, we start by introducing an abstraction layer in front of the supplier code we want to replace. So in most programming languages, this will be an interface or an abstract class. Next, we gradually move all client code to use that abstraction layer. And in the meantime, we can start with a new implementation for that abstraction layer that uses the new supplier code, that is this new library or this new algorithm we want to introduce. And lastly, we can gradually swap out the old supplier code until all client code uses the new supplier code. Now, I have to admit, this adds quite some additional complexity to your code base. You will have to think hard and you will move a bit slower, but it has the immense advantage that you have always working software. You can still perform on-demand production releases at any given moment in time while performing this large-scale refactoring. And you can still add new functionality to your code base and release new functionality while performing this large-scale refactoring. So we are never breaking the flow of work through our value stream. And so we are still able to create positive business impact. And lastly, as a last resort, well, we have feature toggles to decouple feature release from code deployment, something that is called dark launching. So it's a practice where we deploy the code for a new feature days or weeks in advance in production before releasing it to the end user. It gives us the benefit that we can actually test this new functionality in production while it is still invisible for the users. We can even test it under real production load by letting each user perform invisible calls to that new feature. And so somehow it removes the need for having this expensive staging environment that should resemble production, but never really does. It also allows us to gradually release a feature to a small subset of users, a technique that is called Canary Releasing. So we first test with a small subset of users. If everything goes okay, we increase the user base. If it goes wrong, well, we can roll back the feature at runtime by just turning off the feature, which is far less risky than having to redeploy the previous version. Now, in my humble opinion, this is really a practice to adopt as a last resort. You should first master the 3 other practices: working in small incremental steps, hiding functionality, and adopting branch by abstraction. Because while feature toggles comes with their fair share of troubles, if done badly, they can be very evil too. And it can go horribly wrong, like what happened with Knight Capital Group. So Knight Capital Group was a financial services firm which was the largest trader in US equities on the New York Stock Exchange and on the NASDAQ. And they managed to lose $460 million in 45 minutes and went bankrupt because they reused a feature toggle between 2 releases and performed manual deployments on 8 servers and forgot to deploy on one of 8 servers. So they had one server still running the old version with the old meaning of the feature toggle. Ouch. So feature toggles can be a big source of technical debt. So you need to manage them. First of all, like with limiting work in progress, well, we also want to limit the number of active feature toggles. Whenever a toggle is not needed anymore, you need to remove it immediately from your code base. Second, toggles should be independent from each other. So avoid a situation where to turn on a feature, you have to turn on toggle X, turn off toggle Y, and turn on toggle Z again. No, what you want is to have one feature, one toggle. Third, well, when you speak about feature toggles, well, we mean branching logic. Branching logic needs to be tested, and therefore you have to run all your automated tests against your application with both the feature toggle on and off. On the other hand, manual exploratory testing only should happen against the next situation that will happen in production. So if the toggle will be on in production, well, you do manual exploratory testing with the toggle on. When we say branching logic, well, it means introducing complexity in the code base and introducing maintenance problems. So there are many ways on how to implement toggles, and not all of them are good. So Pete Hodgson wrote a very good article regarding this. It's published on Martin Fowler's Bleaky, and it's called Feature Toggles. Now, whenever I suggest string-based development, I always get this same question asked. What about code reviews? How do you perform code reviews when you don't have branches anymore? So first of all, code reviews are optional. It's not mandatory. If your team is mature enough, well, you can assume they will do the right thing. And so while you maybe don't need this extra approval step. And this was confirmed by the book Accelerate, where they found out that both teams using peer review for change approvals, as well as teams not using any peer review, achieve higher software delivery performance. Now, if you still want code reviews, well, we have different options. And the first one is just pair programming or mob programming. You get pre-commit reviews for free. Your code is continuously reviewed while being written and before even committing into mainline. And for many extreme programming shops, this is good enough as a code review. Dave Farley also, well, even reported that this is good enough in high regulated environments like high volume trading firms. Now, if you don't do pair programming, or you do pair programming and still want a formal code review, well, you still have 2 options. And the first one, well, it's the good old pull request model, but this time with short-lived branches. Now, to be fair, I have never seen this work properly, although I've heard very good feedback from people I respect and that say to me, look, it works. Now, my main concern with the pull request model is that the branch runs longer than expected because of the ping pong that happens between the reviewer and the reviewee. And also, my second concern is, well, we are introducing a gating process that blocks the flow of work through our value stream. So it blocks the delivery of our feature. And so it will increase our time to market. The last option we have is what we call asynchronous reviewing. We are going to review all commits after the fact on mainline. And I had a very good experience with this when working with this novice team that did string-based development. And the biggest advantage is that we are never blocking the flow of work through the value stream. So it happens that features get delivered in production before it gets reviewed. Now, you could argue that we run the risk of introducing bad quality into production, and yes, you are right. And while personally, I don't really see a problem here, because while bad quality doesn't necessarily mean a bug, and code reviews aren't there to catch bugs. For this, we have automated tests and manual exploratory testing. But You need team commitment that every commit will be reviewed and that any issue raised during code review is picked up immediately with high priority to make sure this bad quality gets removed from production as soon as possible. Now, what are the benefits of trunk-based development? Well, if we are committing more frequently into mainline, well, we will be able to produce more builds and produce more frequent builds. And so we will be able to deploy more frequently into production, which will inevitably reduce our lead time and our time to market. And so enabling the fast flow of work through the value stream and getting closer to the single piece flow. Now, because we are deploying more frequently into production, well, we will be able to run more experiments, allowing us to try out more ideas and thus uncover more unmet needs of our customers and finding new ways to delight our customers. And so, while increasing customer satisfaction exponentially, which is a huge competitive advantage. Now, because we are building more frequently, well, we will uncover more problems earlier, allowing us to fix them immediately, while they are still small and as such resulting into building quality into the product instead of testing quality later in the product, and thus improving the stability and the quality of our product. So trunk-based development predicts higher throughput and better stability. And this has been confirmed by the 2016 peer-reviewed academic paper, The Role of Continuous Delivery in IT and Organizational Performance by Nicole Forsgren and Jess Humble, and by the book Accelerate by the same authors together with Gene Kim. Both reported that trunk-based development together with continuous integration are a statistically significant predictor of the adoption of continuous delivery. And continuous delivery in turn predicts higher IT delivery performance. And together with a lean management and a generative organizational culture, it predicts a higher organizational performance, meaning, well, you will generate more money for your organization. Now, where is the evilness? It's been 48 minutes that you're speaking and you haven't mentioned once the evilness. Well, and this was an epiphany. The evilness is not so much the problems that are introduced by feature branches, but the evilness really lies behind the use of feature branches, meaning what are the real reasons teams are using them for, which is not necessarily the reasons proponents of feature branching told me in the beginning of this presentation. And in my humble experience, the real reasons are there is a lack of incremental software development skills inside the team, or the code base is too coupled, preventing the team to adopt incremental software development skills, or there is a lack of automated tests, preventing the team to have enough confidence to not introduce any regressions when committing more frequently into mainline, or the build is just too slow, preventing teams to run the build frequently enough in order to commit more frequently into mainline. So feature branching is more like a symptom treatment and not so much a solution to a root cause. And so as a result, feature branching tends to hide the real problems, where trunk-based development will uncover these problems, allowing you to fix them. Now, does it mean that trunk-based development is easy? No. No, it isn't. In fact, it's really, really hard to adopt. It's like with test-driven development, well, we tend to forget how hard it was to get on. Now, it requires a big mindset shift. Many times engineers think it cannot possibly work in their environment. They are very, very skeptical. And from my experience, it takes a huge amount of effort to get them to run a small experiment, especially when you are alone, suggesting this in a team with 6 or 10 people. But once they try it out, and they see all the benefits and they see how much simpler the workflow becomes for them, well, they cannot imagine another world using branches anymore. Thank you for your time. So my name is Thierry Depeau.
Thierry, Thank you very much for doing this, folks. Thank you for staying on mute, most of you, for the most of the time. Now, would you like Theory to turn it into a Q&A, or how would you like to do this? Thank you.
I'm open for a Q&A. I don't know what has been said in the chat.
I haven't really seen any explicit questions, mostly comments and echoing what you have been saying. But folks, if you have posted a question we missed, or if you would like to ask something at this very moment, please just unmute yourself, ask, and go back and mute.
Hi, this is Jairo, and I have a question. I have the opportunity to start with a greenfield project that is going to be game changing for my company. So my question would be, how would you suggest to start with this approach, given that this is a completely new project? Should I first train my teams, or like what will be the best approach in that case?
Well, just do it, I would say. It's in fact, we had the chance that the team I mentioned, the team manager was so clever to say, well, all the existing code base, we won't touch it and we will start over again. So we did greenfield, which is quite easy. And we did pair programming. So I was sitting next to the team members and showed them, well, look, a unit test, you write this like this, it looks like that. And while many times they just don't know how to start with unit testing. It's very, well, it's scary. And I remember when I started with test-driven development, it was really scary. I simply didn't know how to start. And once you see others doing it, for you showing it, well, yeah, well, you start by writing your test, nothing compiles. This is okay. Now we are making sure it compiles. Test is failing. This is okay. Now we are going to make sure the test will pass, and so on and so on. But well, I would really invest quite a lot on pair programming, or at least have your seniors that have experience with test-driven development will sit next to the others. But really have team commitment that every change is covered by tests, and preferably by unit tests, and then it will just work. And whenever your test suite gets slow, well, start investing time in reducing the execution time of your test suite, because this is very important. Does this answer the question?
Thank you. There was thank you very much. If this question was answered to the satisfaction, Jairo, thank you. Manu was someone on this. Could you please just ask a question and go back and mute? Thank you.
Yeah, okay. Mine is very, very short. A couple of slides before this final.
I'm sorry, I mute you. Could you please unmute yourself? Apologies.
Okay. So it was a couple of slides before, Thierry. It was a slide about short. Let me check my question again. How short is short-lived? Is it less than 1 day? The slides don't have numbers, so I can't tell you where it was exactly.
Yeah, so short-lived, well, the extreme programming community said, like, long-lived is everything that is longer than a day. And it's still a number that is hold. Now, if your branches live like a week and you want to shorten them, well, start by trying to shorten by 1 day. Like, yeah, instead of 5 days, go to 4 days, and then try to go to 2 days, and then try to go to 1 day. And once you are at that point, well, try to reduce them to let's say 4 hours, 2 hours, etc., etc. But long running is like, yeah, it's longer than a day.
Thank you.
John Augustin, John, you have I think you have a good question, and Hale. So you guys just throw it out. Do you want me to read it for you, or you want to just say it?
Oh, I can say mine. This is Cindy Hale Dubuque, by the way. I know you only see Hale there. But so I am a Scrum Master for a few teams here in New York. And although I do understand development and writing unit tests and all of that, I always find that with 2-week sprints, there's always a reason why they have to get the feature done and then go back to ensure that they've done the unit test, which they're required to do in order to even merge their PRs and get built once, So I'm wondering how is it, and I'm not the dev lead, right? So I don't lead them, but how is it that we can actually get the team to really try to commit to doing the unit test first before development?
Yeah, that's a tough one. My take on this is, well, reduce the sprint backlog. Start by that, and try to start with a sprint where you actually start by writing tests, and do it the right way, like building quality into the product and taking the time. Also, when the feature is done, also taking the time to do the necessary refactoring that you have identified, and not leaving them like sitting around, because it will bite you at the most awful moment. And then measure how much you have done during that sprint, and then try to plan the next sprint accordingly. But it's really, really important to have this mentality of, well, finishing what you have started, and keeping stuck to the high quality of what you deliver. So a thing I've learned from Ken Beck, so he has this book, Test-Driven Development by Example, where in fact the whole book is in fact where he explains 2 examples. And the one thing he always does is having a list, well, like a paper next to him, and anything he identifies, like, okay, we need to tackle this, but now is not the right moment. Well, I'm going to write this down for later. And then he went once, because he doesn't want to get out of his flow of thinking, which is a thing that is normal. And then once he has finished the thing he wanted to do, he picks up his to-do list again, and then he goes over it. Oh yeah, we've identified this thing we need to do. Okay, we will pick this up, and so on and so on. And it's a thing I've started doing also. I have like, well, I don't do it on paper anymore. I do it on an electronic notebook. But I have this list of things, all the things I identify, like that absolutely need to do. Because, well, if I don't do it, it bites me every time on the most inappropriate moment.
Thank you.
So that's
Yeah.
answer the question.
Anyone else? There was one from Max, was there? I think Vladimir has his hand up. Just go ahead and shout.
All right, thank you. So the question is about the feature toggles. It feels like the impression is that you have a choice not to use feature toggles because they're evil, and you may not want to use them. But, well, how do we actually use trunk-based development and continuous integration without feature toggles if you don't want to release? So feature toggles is decoupling the deployments from the releases. So if we develop a feature integrating continuously and do not want to release it, so what else is available besides feature toggle? Yeah,
so my point is, because I got quite a lot of backfire with introducing toggles as a solution, because well, what I got as feedback was, well, yeah, we tried feature toggles, and it didn't work. It made in fact the situation worse. And this is something that happens quite often, because the main reason is that teams don't manage their toggles. And this is the biggest problem. So no, it is okay to use toggles, and many times you will have to use toggles, especially if you are changing just a small widget on an existing screen, well, you cannot do it otherwise than using toggles. So you have to do it, but you have to manage them. You have to make sure you don't have too many toggles, and you have to remove toggles when you don't use them anymore. Now, and this is where Pete Hodgson wrote some interesting articles, and it's on the blog of Split.io, on managing toggles. And one of his ideas is like, yeah, you can as a team decide, we only have 5 active toggles. And whenever we want to introduce a 6th toggle, another toggle has to disappear, for instance. So it's a way of working. Now, there are different ways also to work without toggles, but well, you will always have somehow a toggle. One is, yeah, when using expand contract, which I haven't mentioned, branch by abstraction is in fact a subset of expand contract. It's a pattern that is quite important for continuous integration. So what you are actually doing is well, in an expand phase, you are adding additional code. Let's say you want to change the signature of a method in your code base. Now, you could just change the signature and then you will have compilation errors everywhere. And then you are spending hours or days to fix all the compilation errors. Or you can just copy the existing method and then do your signature change. And this is your expand phase. So it's copying this piece of code. And then you start gradually replacing the calls in your code base and calling this new method. And once you have done this, and during that you do this, well, you have never broken the application. The application can just be released. And then at the end, when you have finished, well, you remove the old method signature, and this is your contract phase. From there, it calls expand contract. But still, many times you will need toggles. So, but the evilness lies in not managing them and implementing them badly and forgetting to test your toggles and all these kind of things.
By the way, thank you very much for answering, Vladimir. Hopefully your question was answered. Thierry, I'm also being conscious of your timing. We slightly over the time box, and I know it's late-ish for you, so let me know if you need to wrap it.
It's okay.
Another few minutes, maybe we can take another few questions. There was some.
I'm open for more questions, really. I'm passionate about this topic, so.
I have a question, Malik here. You mentioned quite a few times, Thierry, that managing merges was a time-consuming and complex process, and I have a hard time aligning that with my experience. On my current project, where we are roughly 20 developers, I can't remember when I had a complex merge last time. And that is despite us using, I would call it medium long-lived feature branches. They live for a few days or up to a week. But the amount of merges that you seem to incur insinuate a very coupled code base where people try to work on the same code. Did you investigate whether the merges were a result of feature branching or a poor architecture?
So to be fair, most of the time the problem lies in a too coupled code base and too big change sets and people working on same code base areas or features that are not that independent of each other. So you are right. So you will have far more merge conflicts when the architecture or the design of your code base is too coupled. Because then, well, anytime you touch one piece, well, you touch almost, well, a whole area of the code base, which will impact others that are working on their branch, and etc., etc. Especially if you then have to do refactoring, then it's, well, you see what happens. But I agree with you.
Thank you. Not for agreeing, but for explaining.
Thank you for that. We have 2 hands up. I think Caroline and Joel. I'm not sure who was first, but flip a coin or just.
All right, I'll go. I'd be curious to hear about any metrics that you would recommend. Things like We talked about, branches shouldn't live over a day, but any other, number of commits per developer per day, or number of timing of builds, I think just any kind of target metrics that you think would be applicable in a kind of a broad sense to keep an eye out for. I'd be curious to hear what you.
Yeah, so the good metrics are the ones that are mentioned by the State of DevOps report and by the book Accelerate, which are the 4 metrics: 2 for throughput and 2 for stability. So it's your it's lead time and deployment frequency, and it's your failure rate and your mean time to recover from a failure. Now, interestingly, Steve Smith, that I mentioned sometimes in the slide deck, wrote a book about measuring the adoption of continuous delivery, where he applied those 4 metrics to different parts of the continuous delivery deployment pipeline. And so he defined different indicators. So, and he split up the continuous delivery deployment pipeline into the deployment part. So once you have a binary, so you have produced a binary, and then he measures the lead time from there to getting it into production, which is interesting to measure all the activities that happens once the artifact is there. And so, well, especially all the manual testing and all the change approval boards that you have to go through in some organizations. Then he also measures, well, what he calls then the build lead time, and it's everything between the version control system, so committing into version control, and getting a binary, producing a binary. How fast is your build? How often does this build fail? How easy is it to recover from a failing build? These kind of things. And then he also applied that to the version control system, but that is only a throughput indicator. And so you could measure, and you could retrieve this from your version control system, the lifetime of your branches. How long does the branch live? And how often do you merge into mainline? Now, what is interesting about these metrics is not really the absolute numbers as such. What is far more interesting is the trends, how these metrics evolve over time. And then when they evolve positively, well, reflect about, well, what have you done to do this? If they evolve negatively, what has changed in your way of working? And also never compare those metrics between teams, because that is very evil.
We like that word. Yeah, there's lots of things out there that are pretty evil, right? Thank you for that clarification. Joe, hopefully that was a good response for your question. If you don't mind, I'll pick and choose. So Carolyn, you were next in line, I think, wanted to ask something. If you still are interested, please ask.
Yeah, thank you. So I was wondering, because you explained about the root causes of not going into this trunk-based development, and I'm actually a developer in a company with a cross-location, so 40 developers, multiple products, lots of technical debt, no unit testing. The testing is fully manual, and we are having a hard time switching to trunk-based development because the main arguments are we don't have automated tests, so we have to get the release out to the customer, and to protect ourselves from regressions in master, we branch for 3 months, and then we stabilize this branch so that we're able to manual test and fix the regressions on there before releasing a software version. So I was just wondering if it makes sense that we fix the root causes before switching to trunk-based development, or is this something that you can just go full in and then there is not so much risk as I'm imagining?
Well, there are 2 takes on this, and it depends how you feel with this. You could just say, well, we just switch to trunk-based development and we cope with it, and we fix everything that breaks as it comes. But it can be very stressful. So it depends on your team. There is a far more less stressful way of doing it. Is well, it's defining well some kind of vision and adopting a continuous improvement framework to help you with this. So it's a thing I've done with an organization I've helped like in 2018, which came to me with the exact question, well, look, we are releasing twice a year and we want to release every 2 weeks. And yeah, by the way, we want to do this in 4 months. And well, what I've suggested then was like, yeah, we are not going to switch like this. We've introduced the improvement kata. So the improvement kata is a continuous improvement framework where you start by defining a vision. And for you, the vision could be, well, we want to adopt string-based development. And it's a thing you want to achieve in a far, far future. And then you start by analyzing your current situation. How does the process look like? What is preventing us from doing this? Which data do we have, etc., etc. And then you start by defining improvement targets you want to achieve. What is your first improvement that you want to achieve? And this target should be, well, something measurable, like an acceptance criteria. It could be, well, we want to reduce our lifetime of branches from, let's say, well, they take 2 weeks and we want to reduce them to 1 week. Or another thing could be that, yeah, you identify that, oh yeah, we have too few tests, or our tests are failing too much. So you could then define a metric like, yeah, we want to reduce our failure rate of the builds, of the tests. And we are going to try out many, many experiments to do that. And so you move on. I have a presentation about that that you can find on my website.
Okay, I'll do that. Thank you.
You're welcome.
We're going to have a link to your site so people can always browse it. Thank you. Next question, Trent, I see you raising your hand. Great to see you here. Could you please voice it?
Hey, Gene, can you hear me okay?
Yes.
Okay. Yeah, so it touches on kind of piggybacks off of Carolyn's question. So ultimately, my assumption is, based on sitting through this, that, you know, what you're proposing with trunk-based development is difficult without a high level of code coverage. And I think you kind of answered that, but I guess the question being, you know, would you put a lot of emphasis on that in terms of, to be able to lower that level of stress that you mentioned in terms of making a big switch, especially with the large existing product with a large code base and very low amounts of automated tests?
Well, yeah, so somewhere you should increase your coverage of tests, or at least have a good coverage for the core functionality. Maybe not for your whole product, but for the core functionality. Well, it would help you in having some more confidence to do this. And I know this is hard and it's difficult to adopt, and it seems a very, very long way to go. And as I said, we were lucky we could start from greenfield, so it's far more easy.
Yeah, my thought is on, you know, some of our newer development, that's, I mean, ultimately a new tech stack, and it's kind of redoing parts of the existing system. That's a great place to start, to be able to put that in. And then, you know, assuming we get to a really good point and we're doing that in that part of the system, then we can look at the legacy part.
Exactly.
Thank you. Great presentation.
Thank you.
Thank you for the question, Trent, as well. Good to see you here. See some more hands. So still, I think Vladimir is still having your hand up. Do you have another question you would like to ask?
Nope, I'm good, thank you.
Or Carolyn, same. Folks, feel free to just shout out if you have any questions. I think we are, you know, we are okay to wrap it because we're over the hour But if you would like to have another question thrown at Thierry, please do so.
Will the recording be available after this?
That's good. Yes, as soon as this finishes, it should go to the cloud, and I'll pick it up from there, and I'll make it available along with some additional assets that Thierry shared and some of the quotes I captured from his presentation, as well as the links that many of you have been pinging in the chat. I'm asking you to post it on the page that I shared, so it stays there for those that want to come back to it. So we'll have this for you, as well as the Thierry's website where there's more great stuff.
Thank you.
Okay.
Well, thanks, Thierry. Take care.
Thank you.
Well, I guess if there are no more questions, I would like to give you all back your Sunday time. Enjoy the rest of the weekend with your families and everyone. So Thierry, personal thanks to you. It was a great pleasure hosting you. It was an amazing talk. Thank you for coming out and doing this at your time, which is late-ish, right? And I'll be happy to maybe have you back at some later point if you have any ideas or whatever. And I encourage you folks to reach out to Thierry directly if you have any questions or anything that you would like to discuss privately. Okay. Great. Thanks. Thank you, everyone.
Thank you.
Thank you. Bye.
Thank you.
Enjoy the rest.
Take care.
Cheers. Thank you very much.
Thank you so much, Thierry. It was awesome. Thank you.
Thank you. That's very nice.
Bye-bye.
Great. Thank you.